Welcome back to section 316. We're just going to talk about more of the same. We're going to be talking about these exponentials. For the first few, we're just going to give a little context, potentially. So looking at the graph could be the value of a new car over the years. So when you purchase it, you spend a certain amount of money, and each year it goes down in value. For problem number 2, it's growth. So it could be maybe the value of a collectible that's gaining value each year. For number 3, we're starting at a big number like 226 million. It could be like the value of a company as it's increasing each year, or even the population of a country. Just giving some potential context to a problem. Now we're going to be using this information we've been talking about. So now let's skip problem number 4. We're not going to worry about this one. So here's something. Annual fees for a public university. $1,200 in 1986, and it's increasing as we see. So we can write an equation. So just like we did in the last section, x and y, so we have 0, 1,200, 1, 1,320. So what we can do is we can find our multiplier. 1,200 times b equals 1,320, divide by 1,200, and b equals 1.1. Now a, our initial, our y-intercept is 1,200, so our equation y equals our initial a times b to the x, 1,200 times 1.1 to the x. And there is our exponential growth. So what we can do is we can use this to find out what the cost would be in the first year you would be eligible. So for example, the first year, since many of you will be graduating next year in 2021, the first year would be 2022. Sorry, I think you're the class of 2022. So the first year would be 2022. So x equals 2022 minus 1980. So that would be 42. Oh, sorry, 1986. So it's not 42 at all. So it'd be 36, excuse me. So y equals 1,200 times 1.1 to the 36. So you're going to be about $37,095.22 approximately. So that would be the first year for most of the people in this class. Scary numbers. Now, let's go to the next problem. What would be the cost in 1980, assuming that it still had the 10% increase? So we're still using y equals 1,200 times 1.1 to the x. Now, x equals 1980, our current year, minus 1986, our starting year. So x would be negative 6. We're going backwards. 1,200 times 1.1 to the negative 6 would be about $677.37. So about $677.37, 6 years prior to that first one. Now, what actually happened is that in 1993, the actual cost was $3,276, excuse me. So if we look at this, the model, 193 minus 1986, x equaled 7. So it's 1200 times 1.1 to the 7th. So the model is saying that it should be $2,338.46. Now the actual cost was $3,276. It's actually $900 more than expected. So what that's telling us is that the fees actually grew more than 10%. Our fees grew more than 10%. Now, if we look at problem number 6, we're not going to make a table, but we can look, and we know that our initial is 5, and our multiplier is 3. It's growth. So looking at this, I know my y-intercept is going to be at 5, and it's going to be growing each time. So it's something like this. It's going to grow pretty quick, but there's a quick graph of what it'll look like. It's a growth model with that y-intercept at 5. Now, 1/2 is between 0 and 1. This is going to be decay. It's going to fall from left to right, and our initial is 10. So our y-intercept here is at 10, and it's going to be falling from left to right. It's decay. This is growth, again, for part C, because our multiplier is 5, and our initial is 1/10. So our y-intercept is at 0, 1/10, and it's going to be growing from left to right. That's just a rough sketch of what it would look like. So we're just going to finish up doing some more word problems based on exponential growth or decay. So here we have a 100-gram sample of radioactive isotope that decays at 6% every week. How big will be the sample 1 year from now? Notice that it's 6% every week. So y equals A times 1 minus r, because it's decaying, to the t. So y equals our initial is 100 times 1 minus 0.06 to the t. So y equals 100 times 0.94 to the t. That's our model. Now, how big will it be in 1 year? Now, 1 year, 1 is not our exponent because it's every week. So 1 year is 52 weeks. So be very careful of those units. So y equals 100 times 0.94 to the 52nd. So you're going to get about 4.005. So about 4 grams remain after 1 year or after 52 weeks. On the next page, math club's getting more popular because of that Pi Day activity they do. So it's increasing 30%. 45 members. We're going to write a model first. It's growth. Y equals A, 1 plus R to the T. Our initial, we had 45 members. 1 plus 30% is 0.3 to the T. So Y equals 45 times 1.3 to the T. There's our model. We can use that for any year. So now T is going to equal 5. So we're looking at 5 years. So Y equals 45 times 1.3 to the 5th. And you're going to get about 167.08. So since they're people, we'll round down to 167 members. We're just using these growth and decay equations we've been coming up with. Barbara made a bad investment. So rather than earning interest, she's decreasing. So it's decay. 11% each week. After just 1 week, she is down to just $142.40. How much money did she start with? So it's decay. Y equals A times 1 minus R to the T. So Y equals A. We don't know the initial. 1 minus the rate, which is 11% or 0.11 to the T. A times 0.89 to the T. Now, if in 1 week she's down to $142.40, what we can do is we can go backwards. So what we can do is 142.4 divided by 0.89, that would give us our initial of 160. By dividing by that multiplier, we're going backwards. So our model, Y equals 160 times 0.89 to the T. Now, the next part is a little bit trickier. How long will it be before she has less than half of what she originally invested? Now, half of 160 is $80. So we're doing a little guessing check here. So Y equals 160 times 0.89 to the T. So 80 equals 160 times 0.89 to the T. So when you guess and check, you're going to find out that in 6 weeks, when T equals 6, you're going to have about $79.52. So about 6 weeks for her to lose half of her money. That's a tricky one. And then the last one, Larry loves music, so he bought $285 worth of MP3 files on his credit card. Now he can't afford to pay off his debt. His credit card company is charging 8% interest compounded monthly. So we see that compound. So now how much would he owe at the end of the year if he had no payments for 12 months? So Y equals A times 1 plus R over N to the NT. We're using that because we're compounding monthly. So the rate is 18%, which is 0.18, and N is 12. And our initial is 285. So our model, Y equals 285 times 1 plus 0.18 divided by 12 to the 12T. That's the model. We can use that for any number of years we want to. So how much would he owe at the end of the first year? So for 1 year, that's when T equals 1. So Y equals 285 times 1 plus 0.18 over 12 to the 12 times 1. So Y equals, when you type that in, about $340.75. That's why it's always important to try to pay off your credit cards each month. If you don't pay them off, they're going to gain. You're going to end up spending a lot more for your purchases in the end. Okay, so that concludes talking about exponential growth and decay. Make sure you have those formulas written down in a nice, easy to locate spot so you don't have to keep searching through your notes to find them. Thank you, and I'll see you in the next video.